Today we are going to do ripple counters, experiment 7 of ROBO 124 digital electronics. Objective is to construct a mod 16 counter, BCD counter and a down counter. Please change it. It's a down counter. So mod 16 counter is going to count from 0000 to 1111, which is 0 to 15. BCD counter is going to count from 0 to 9. Down counter is going to count from 7 to 4. 7, 6, 5, 4. First circuit that we are going to build is mod 16 up counter. Up means counting from 0 to 16. We are going to build this circuit. It has two 7476 ICs. 7476 ICs are dual, so two JK flip-flops are going to be available in each of the IC. So one will have two of them, the next one two of them. I have put the pin numbers for you to make connections. Function generator is going to clock the first JK flip-flop. So you have to set function generator in square wave mode, 1 Hz frequency, 4.5 volts peak to peak. This push button could be done by a wire. Connect 3 and 8 of all of these flip-flops and connect to 1 kilo ohm resistance. From the same end, take a piece of wire and 1 kilo ohm resistor's other end has to go to plus 5 volts. When you start the experiment, after hooking up everything, you have to connect this point, which has a small wire, to ground to start the count sequence. Now, pin number 15, pin number 11, pin number 15 of the second IC, pin number 11 of the second IC, they have to go to these pins of 7447, which is your decoder driver. Q0 is the least significant bit, Q3 is the most significant bit. That is going to go on to 7447, and we are going to connect these pins to the 7-segment display, and we are going to get the display of the counts, like 1 to 9 could show up on single display, 10 to 15 would be through the LEDs. I have hooked up the circuit. This is the 7-segment display that can count from 0 to 9, and I have also mounted the LEDs from those same pins 15 and 11, 15 and 11 to show the outputs from 1010 to 1111, like count 10 to 15 could be through these LEDs. This is the push button I showed as a wire. So this push button has to be grounded initially to start the count sequence, and when you put in ground, the count is 0. Okay, when I take out this, the count sequence would start from 1. On the display you can see 1 to 9. You can also verify through this. This is the most significant bit position and this is the least significant bit position. So you can look for 0000 to 1111. All of them would go in sequence. Now I am taking away the push button. One zero one zero 1011 1100 1101 1110 1111. Now let's do part 2, which is BCD up counter, that has to count from 0 to 9 on your 7-segment display, and on the LEDs you should see 0000 to 1001. The count sequence is adjusted with these two gates 7400 and 7408. When the count 1010 comes, it's going to be given to the reset inputs of 74LS76, and it is going to reset all of them to 0000. Okay, we have built a NAND and arrangement on this breadboard. Pin number 1 of 7447 and pin number 6 of 7447 are brought to pin number 1 and 2 of 7400, and the push button arrangement that was there is brought to here 7408 pin number 2 gets this resistor, and the other end of the resistor goes to VCC. Now this is the push button that has to be grounded to start the count sequence. I have grounded it. When I take it out, the count sequence starts. Now when it goes to count 9, what you're going to do is you're going to again push the push button and start from 0. If you wish to make a BCD down counter that could count from 9 to 0, what you need to do is these outputs are coming from Q0, that is Q outputs of the IC of 7476. If you just change it from here to here, the Q bar outputs, then you're going to get a down counter that counts from 9 to 0. Now let's do part 3, down counter. The connections are here. Note the pin numbers. We have to make some changes like these ones. When you adjust the connections as shown, you're going to get the count sequence from 7 to 4. Let's see it on the board now. Here is the push button, and I have connected it to ground to start the count sequence. So when I put the push button here, you see 7 is lit. Now when I take it out, 6, 5, 4 and back again 7, 6, 5, 4. Thank you for watching.